All right, let's dive into the world of tech. Today, we are going to be decoding that crazy alphabet soup of acronyms that, just seems to be everywhere. I mean, have you ever been reading an article about a new gadget or just trying to set something up and felt like you need a secret decoder ring? Yeah, you're definitely not alone in that. These letters, they pop up all over the place, from setting up your Wi-Fi to signing up for some new online service. But believe it or not, they aren't random. They are the actual building blocks of our digital world. And today, we're going to make sense of all of them. And here's how we're going to do it. We've got a roadmap. We'll start with the actual hardware inside the box, then we'll move on to how that box connects to the internet. From there, we'll cover how we keep it all secure, and finally, we'll look at the software we all use every single day. Okay, first up, the computer's core components. We're talking about the tangible, physical parts you could, actually hold in your hand. This is the essential hardware that makes everything else even possible. So at the very heart of it all, you have the CPU, the central processing unit. Honestly, the easiest way to think about it is as the computer's brain. Every single click, every keystroke, every command, it all gets processed right here. It's the engine doing all the heavy lifting, all the thinking. Now, if the CPU is the brain, then RAM, or random access memory, is its short-term memory. It's kind of like the computer's workspace, where it keeps everything it's actively working on at that moment. You know when your computer slows to a crawl because you have way too many browser tabs open? Yep, that's your RAM hitting its limit. The more RAM you have, the more you can juggle at once without things getting sluggish. Now let's talk about storage, long-term memory. A hard disk drive, an HDD, is the more traditional option. It has actual spinning disks inside, and it's great for storing huge amounts of data really cheaply. But the solid-state drive, the SSD, is the new king. It has 0 moving parts, which means it is lightning fast. That SSD is the real reason a modern computer can boot up in just a few seconds instead of, a few minutes. So what holds all these different parts together? Well, that's where ATX comes in. It stands for Advanced Technology Extended, and it's basically the standard size and shape for most desktop computer motherboards and cases. It's the blueprint that makes sure all these different parts from different companies can actually fit and work together perfectly. Okay, so we've built our computer. Awesome. Now, how does it talk to the outside world? Let's dive into how these machines connect to each other and to the internet. We can start with 2 basic types of networks. Your Wi-Fi at home, that's a LAN, a local area network. It just connects all the devices in your house. The internet, though, is the ultimate WAN, a wide area network, connecting literally billions of devices across the entire globe. It's a massive difference in scale. So, how do we navigate that giant WAN? Well, when you type in a website address, a system called DNS, the domain name system, kicks in. It's basically the internet's phone book. It instantly translates that human-friendly name, like google.com, into a numerical IP address that computers use to find each other. And all of this happens in the blink of an eye. It's pretty amazing. Speaking of those IP addresses, how does your phone or your laptop even get one in the first place? Well, that's thanks to DHCP, the Dynamic Host Configuration Protocol. You can think of it as the friendly gatekeeper on a network that automatically hands out a unique address to every single device that connects. It's the reason why joining a new Wi-Fi network is usually so seamless. So we're online, we're connected. But with that connection comes risk. And that brings us to our next critical section, the language of security. Let's talk about proving you are who you say you are online. It usually starts with something simple, like a PIN, a personal identification number. For a bit more security, you might use an OTP, a one-time password that gets sent to your phone. But really, the gold standard today is MFA, or multi-factor authentication. It combines these methods, so a hacker needs more than just your password. It's like having multiple different locks on your digital door. So what's the stuff we're trying to protect? A lot of the time, it's our PII, which is personally identifiable information. This is any piece of data that can be used to pinpoint you specifically. And it's not just the super obvious stuff like your social security number. It's also your email, your physical address, even just your full name combined with another detail. And I mean, think about it for a second. Every single service you sign up for, every online store you buy from, they're all collecting little pieces of your PII. So it's a really good question to ask yourself every now and then, who actually has my data? So how can you add a layer of protection, especially when you're on a public network like the Wi-Fi at a coffee shop? That's where a VPN, or a virtual private network, comes in. It creates a secure, encrypted tunnel for all your internet traffic, basically hiding what you're doing from any prying eyes and protecting your data while it's in transit.
All right, we've covered the hardware, the network, and security. Let's move to the final layer, the part we actually interact with every day, the software and the services. A lot of today's software is delivered as a service. You can think of it kind of like building a house. IaaS is like renting the raw land and the basic materials. PaaS gives you the land and all the tools you need to build. But what most of us use every day is SaaS, software as a service. That's like moving into a fully furnished apartment. You just log in and use it. Think Netflix or Gmail. It's ready to go.
And whenever you use that software, you're agreeing to a ULA, the End User License Agreement. You know what this is. It's that huge, long legal document, the terms and conditions, that you probably just scroll past and click Agree on. Well, that ULA outlines exactly what you can and cannot do with the software you're about to use.
Phew. Okay, after that whirlwind tour, let's just step back for a second and put all of these pieces together. Let's really decode this alphabet soup once and for all.
When you look at it all, you can really think of technology in 4 distinct layers. It all starts with the physical hardware, like the CPU and the RAM. That hardware then gets connected through networking, using things like DNS. We protect our data with security measures like MFA. And then we interact with all of it through the services on top, like all those SaaS applications we use. So you see, these letters and abbreviations, they aren't just technical jargon to make things confusing. They represent the fundamental concepts that make our digital lives work. Understanding them is basically a new kind of literacy. It's the language of the modern world. By breaking down this wall of acronyms, you're no longer just a passive user. You're an informed participant in this digital world. You actually understand the how and the why behind the scenes. So the only question left is, now that you speak the language, what are you going to do with that knowledge?